This is my latest electronic edge finder. There's two things about it that are different than my previous versions. The first is that it has an output that can communicate with CNC program, so it can be used for automatic touchdown. I'm running Centroid CNC 12, which I'll show you in a minute. The second thing, which is kind of unique, is that it's mostly in software. So if you look down here, that little tiny device, it's 4/10 of an inch on the side, is most of the functionality. That's called an AT Tiny 85. If you buy them in single quantities, they're less than $1.50. And there's not much else on this little board, just a few components. Most of them are used for automatic power down. Now, over here is this massive clip. It's actually capable of carrying 50 amps, but I'm only passing 50 milliamps. The reason I like it is it's nice and big, and it can easily clip onto my probe. It's also a part of what I call a modified Kelvin connection. So I've got two wires coming in, it's a little speaker wire, and one wire goes to each half of the jaw. So when it connects on there, it's a close approximation to a Kelvin connection. The other half, the Kelvin connection, you can see here, it's the two red lugs that go to diagonal corners of the circuit board, and in that way they have independent connections to this piece of aluminum channel, which in turn is resting on the table. And that, to my own surprise, is actually a very good electrical connection. So all I do to use this is take my clip, and I'm just hooking it onto a piece of 3/8 inch drill rod, no insulation or anything. And the next step is, here's my bridge. The bridge has inside of it a red and a green LED, plus the body of this is connected to the hardware and ultimately to the Arduino computer. So when I touch this and bridge the gap here, it's going to take about 400 measurements and determine what touchdown looks like. Then it's going to turn off the LED, and that tells me to take it off there. When it turns back on, it's taken another 400 measurements and determined what it looks like when I'm not touched down. At that point, I can turn on the auto touchdown code, and it'll feed this piece of drill rod in until it touches the reference. It touches it quickly, backs off, goes in slowly, and at that point we'll look at the result and see what touchdown is. Now the one reading won't mean much, but I'm going to do it twice and you'll get a little sample of repeatability here. So the first thing I do is touch it. It's already done with 400 readings. Now it's turned back on. That means it's done its second 400 readings. Now I'm going to just run the CNC code. Oh, see, it's so fast. So it's done its first pass. Now it's coming in for its second pass. It's already done. So if we come back here, you can see that it says it has touchdown at a machine position 6.1030. So keep that in mind. That's the first time it touched down. So as a bare minimum, if I run this twice, let's see how close I get to that same number. If it's way off, then if repeatability is poor, obviously this is worthless. So we come back over here, and right now it's touching. So I'm just going to jog out a few and start over again. So I take my bridge, take it off of there. Oh, it didn't like that. Do it again. Okay, this time it did. I'll get into what that flashing was a little later. So now let's start. Touchdown, going in again. Because this is not a mechanical switch, I don't have to back away very far. So I'm backing away about 5,000. And coming over here, you can see that instead of 6.1030, I'm now 6.1033. So it's 3/10 different than it was. Come back here. I'll just do it one more time. Okay, it's happy. You see that flickering, I'll explain that too. Okay. Now, come back over here, and this time it's 6.1029. So there's a small variation. It is not a variation in my circuit. It's a variation in actual distance to touchdown. Because the circuit itself is just looking for contact closure. Now, there were a number of different patterns of light flashing here. The most common one was turning green and turning off and then turning green again. That's normal. The other flickerings actually have a lot of meaning. When you saw flickering when it was feeding in, it was giving me a live readout of exactly how close I am to various thresholds. So when I'm more than halfway away from the threshold, I get solid green. If I'm between half and a quarter, I get a slow flicker, which is what you saw. If I'm below a quarter but not tripped yet, I'll get a fast flicker. Didn't see that, but that would be a warning that you better be careful because the touchdown might be premature. And then finally, when it turns red, it's touchdown. So, not interested in forcing failures, but let's see what we get. We'll do one more touchdown. Okay, it's happy. And notice that it stays red. That simply means that after touchdown it stayed where it was. And notice that now it's turned off. That's because 10 seconds after the first touchdown, I have an automatic power down. That's plenty of time for CNC 12 to come back and do its second touchdown. Now, by doing that, I get incredible battery life, well in excess of 2,000 cycles on a set of batteries. Now, come over here, and this time we're at 6.1035, so it's a half a thou. So there's some variation. My guess is it's flexure or vibration caused by this long rod. Doesn't take much when you're talking about a half a thou. So I'm in the process of writing this up, but I thought I would share what it looks like now.